Hello everyone, welcome to my 3D scanner tutorial for Garry's mod. So in this video we're going to be building this contraption that you're looking at here, or at least one that works the same. It doesn't look exactly the same and it doesn't do what it does in the exact same way, but it does the same thing in the end. So just in case you're unfamiliar with how it works, you press a button and it will start spinning around, and in my particular build the beam here also goes up and down very rapidly. And then when you place something in there, like yourself, it starts to scan you, or whatever prop you have in there, and then emits that over here so that you can look at what you've scanned. So this is what we're going to be building. So yeah, let's just get to it. We're going to be using slightly different props, as I said. These props over here will be for the main module. This will just be for the control panel, and this will be for showing what we've scanned. Now, these particular props are called SButtons, which is from a mod that I've downloaded online. I recommend them, but in case you don't have them and you don't care to get them, you can also use builder props. I mean, it doesn't have to be the exact same. You could use something like this or this. You know, there's a lot of things that will work here. So yeah, let's just get started. You're going to start out by using this disc that you have, and in the original build I had thrusters to make the thing go, to make this disc spin, but we're going to be using the wire motor instead. So go into wire, physics, force, and then motor. Set the torque to be 1. Set the force limit to be high. Doesn't really matter how high, just it has to be kind of high. And the hinge friction, we're going to set that one to 0. It makes things easier. And we're just going to click the center and the center on this one and just connect them there. And then we're going to be putting the controller somewhere. I'm just going to put it below here. You can put it wherever you want. It's not really important. So we're going to put that one there. Alright, and now they can spin. And then, if you have it, use the stacker to then make a third disc on top of the second one. That should be welded and frozen, like that. If you don't have the stacker, you can just do it by eye or whatever other way you can think of doing that. But this is what it needs to look like. So you have two discs, one above and one below the center disc, which can spin. So just like that. Now we're going to use these guys here to have a place for the Ranger that's going to be doing the actual scanning. So the way we do this is just we get the no collider tool and we no collide this prop with the center disc, and we slide them into each other here, just most of the way in there. Don't need that much pointing out here or sticking out here. So let's see if we can make that somewhat center here, something like that. And then we weld these two together so that it will spin around with it. And we're just going to leave this one for now. So that works. Alright. And let's just build the platform for the for showing the result here. I'm just going to axis this one center to center so that we can spin the result around here. It's not really spinning very well. Oh, there we go. Okay. So that's really most of the work done. In the control panel, we're just going to put that floating in right here. The beautiful color here. Something like that. That works. Alright. So now we start with the actual wire things. Or, well, before we do that, we're just going to put the hydraulics on this thing. So freezing everything here. And trying to get this one to be aligned here. It's a little bit difficult to do, but let's see. Just trying to make the lines line up here. Actually, just lift it up a little bit. Otherwise, I can't do what I want to do. That's pretty good. All right. Now you're going to wire physics and then constraints and hydraulic. The in-out speed multiplier should be 1 and fixed should be checked. Everything else doesn't really matter. At least I don't think it does. I'm not really entirely sure about that one up there. So now underneath the red prop here, I'm gonna go to the second node here and then right click so that it automatically connects directly down. And the controller I'm just gonna put somewhere, doesn't matter. And then once again doing the same but from the other side, so second node here, right click and place a controller. There we go. And now hopefully this won't go crazy if I release it. It does. Okay. See, the thing is about hydraulics, they're really very annoying to work with sometimes. So we're gonna have to try over here. You're probably gonna have to do the same thing, unless you're lucky, because hydraulics are just a pain in the butt to work with. So let's try again. Maybe we get lucky this time. There might be some trick to it, but I don't know what it is. So let's try again. I'm gonna try the third node this time. If it doesn't work this time, I don't know what I'm doing wrong. Alright, let's see. Alright, I think that's working. Okay. So this time it worked. Alright. Let's see if it can spin without going crazy. Okay. So that looks pretty solid. Let's see, what do we need to do now? We need a Ranger, of course. So let's go to Detection and then Ranger. And you want the... You don't actually want the distance, you want the output position. And the range should be something that... so that the beam just reaches to the other side. I'm gonna place that center here. Whoops. Oh, come on. Okay, let me just freeze that first because it's being difficult here. There. And let me just lift that up so I can see where the beam goes to. Okay, so it needs to be slightly longer range here. Let's try 95. That's pretty good. That's good enough. All right. Now, I need to just find out what I need to feed the controllers here in terms of length, so that it rests at this height. I don't want it to be pointing into this thing, and it also tends to spaz a little bit if it has too little height to work with. So I'm just gonna experiment to see which number I need to give it to actually go up there. So this is just for debugging, if you will. I'm gonna go ahead and use a constant value. Let's start out with the number 10 and see what happens. Actually, put it down here. And let's just wire this up. So length to here. Let's see, that's a bit too much. It's quite a bit too much, in fact. So let's try 5. That's a little bit too little. Let's try 7. No. 7. There we go. Still a bit too much, actually. Let's try 6 then. Yeah, that's pretty good. That's pretty perfect, in fact. So now I know 6 is the number that we're gonna be using. All right, now for the actual expression chip that we're gonna be making here that will be doing all the work for us, really. So I've just made a chip, and all I've done is I've called it 3D scanner. So nothing else. Let's just go ahead and place that here. Alright, so we're going to need a few buttons. We're going to need a button for turning things on and off, right? So a toggle button 1 and 0. And then we're going to need a button for clearing the scan when we don't want to look at it anymore, or we want to scan something else and we don't want the old thing to be there still. So let's go ahead and make 2 buttons here. The first one should be a toggle button, and it should be a that should be the start button. And go ahead and put that I don't know, there. And then the clear button should not be toggle, and we're going to put that right there. Actually, right there. Okay. So, yeah, what do we need? Okay, so the first thing we're going to be doing is we're going to be making the center platform spin at a constant rate. We don't want it to be jumpy or to be slowing down or speeding up or whatever. We want it to be maintaining a constant speed. So the first thing, of course, that we need to do is we need to have some way of figuring out how fast it's going. So go into the detection and then speedometer, and make sure you check angular velocity outputs. I'm just going to place that on the spinning plate. Whoops. Here. Nope. There. Okay. Let's just make sure it can still spin. Yep, that's working. Okay. And then let's make an input for speed. All right. And as an output, of course, we want a torque to the motor, right? So for right now, let's just well, actually, let's have the start button, SButton, as well. And let's just focus on keeping a constant speed right now. So WSpeed will be short for wanted speed, the speed we want to maintain. And let's try setting that to 50 for right now. I don't really know what 50 means in terms of speed, but let's just try setting it to that and see how fast that is, whether or not we like it. So the first thing we're going to do is we're going to check whether or not the start button is 1, right? So we do that by just saying check if SButton. And if SButton is on, we want the following to happen. We want to figure out what to set torque to be equal to. And the expression for doing this, I think I'll make a more general video on how to maintain things, how to do these systems that will maintain a certain value. But for right now, I'll just give it to you. So it's some number which you'll have to figure out which works best for you. But in our case, let's try 20 times, and then the difference between the current speed and the wanted speed, or the wanted speed minus the current speed, depending on whether applying positive torque gives you positive speed or positive torque gives you negative speed, which I don't really know at this point, so we're just going to try with this. If it doesn't work, it's just going to keep accelerating and go crazy, so you'll know you've made a mistake there, and you'll just have to turn these two around. And then you subtract from this the difference in speed. So you make this sign and then speed, and that will give you the change in speed from each time it runs the code. In other words, it's the acceleration, right? And you multiply that by a number as well, and I like to make this number bigger than the number over here. If it's too high, things will get jumpy, so we'll see what happens. So for right now, let's just go ahead and try this, see how that works. I'm going to use the debugger on the speedometer to check the velocity, and the velocity we're using is the angular velocity y, because that one has a sign, so we know whether we're going clockwise or counterclockwise. If not, then things go crazy, and we don't want that. So let's go ahead and wire the start button here. Oops, start button. And the speed, like I said, will be angular velocity y. And then we're going to say torque, or the multiplier here from the motor controller is torque. And let's make sure everything's unfrozen. I think it is, yes. And then let's try pressing the button and see what happens. It's moving around at 49.8 something. So that's working pretty well, right? That's working pretty well, but it's going pretty slow, and it's not really slowing down when we turn it off. So for starters, let's say if the button is not on, that is else, we want the torque to be, and we're going to use the same expression, but this time, of course, the wanted speed is 0, so we just plug in 0 where wanted speed is before. So in other words, we just get speed, right? And then minus 50 times the change in speed. There we go. All right. And as you can see, it slows down. Whoops. Once we have the button to be 0. It's a little slow right now, right? It takes a while to accelerate and decelerate. So that tends to mean the first value here, the first constant, is a bit too low. By setting that one to 40. And we're going to keep the other one at 50 for now. See what happens here. Pretty good, I suppose. But let's try setting the wanted speed quite a bit higher and see if the constants are still working at that velocity. Pretty good, but as you can see, it's not perfect, right? It sort of goes a bit too far and then slows back down. So let's try setting this constant over here to 80. See if that works. That's actually a bit too much. I think I might have set it too high now. I don't know. Let's try 60 in this one. It's not really important. I mean, you can... I think I made it worse, but whatever. We'll go with this. It's okay. It's fine. It's fine. And what about the speed? It could go a little bit faster, so let's try setting it to 200. Yeah, that's a good speed there. Alright, the next thing we're going to want to do is we're going to want to increase the hydraulics length. Now, when it's not scanning, we want the hydraulics to go back to starting position, and as we found out, the starting position was at 6, right? So for outputs, we're going to want the hydraulics length, we're going to call that length, and we want length to be equal to 6 when we're not scanning, and when we are scanning, we want length to be increasing, so we say plus equal by some number every time we run the code. I don't know what that number should be, but let's try something fairly low, because you have to remember it runs the code quite quickly. So let's see what happens if we do this. Oh, of course, I have to wire up the controllers, otherwise nothing's going to happen. So length here, same one with the other controller, there. Okay, so now as you can see, it went up there. So let's see what happens when we turn it on. It starts moving upwards, I think. Yes, it does. Now whether or not it's doing this too fast or not, you can always just change the number, but this seems to be pretty good. Now you might notice a problem here. This platform with the Ranger on starts to move farther and farther away from the center, simply because it's spinning around, right? In this particular build, it's not too bad, but as it gets higher, it will do it more, and if you turn up the rotational speed, it will also do it more. And one way to deal with that... Ooh, it's going crazy now. Yeah, okay. The hydraulic is not too stable here, unfortunately, but most of the time it will be. But one way you can deal with the problem is to turn down the weight of this platform here. It's 24 here. I'm going to try setting it to 15. Okay, that made it go up a little bit, so you might want to set the resting height lower, but I won't do that for now. But that will make it like swing out less. But anyway, for the tutorial, I'm going to be happy with this. This looks pretty good. Alright. So now we need really just to show what we're scanning, right? So go into wire, and then visuals, and then holographic, and holo emitter. Alright, these settings here are not really important. gonna set that to the center. There. And that will now spin with the platform. Maybe. Will it? There we go. Okay. And yeah, so let's just get the code for this. Let's just get the code for this. And I need to just make sure. Okay. So the things we need to worry about are the position of the point. Local needs to be set to 1. Color, we can mess around with that if we want. I don't think I will. Size needs to be set to something so that we can actually see it. Clear is to the button, and active should just be 1 all the time. We don't really want it to not be 1 ever. I think I'll just make a constant value for that. Place that right there. So active is 1. The clear is to the clear button. And local is also 1. We'll put that there as well. Okay. And let's just, in this constant value, make one more value. I'm going to set that value to be like 5. There. And we're going to wire up the size to that value, 5 there. So right now the size is 5. You can, of course, change this any way you want. But I'm going to be happy with 5. This thing is not spinning. Okay, whatever. So let's go ahead and make the code for this. All right, so the input would be the Ranger, whatever the Ranger's hitting, right? The Ranger's going to hit something. It's going to hit a point, and it's going to have the coordinates of that point. So that's going to be a vector, right? A 3-dimensional vector. Okay. And the output will be the position, and that's also going to be a vector. So what do we want to do? Well, if the scan is going on, so that's up here, right, in the if statement, we want the position to be equal to oh, actually, you know what, I've forgotten something. Sorry about that. We need, before we do this, we need to have a GPS. So just a GPS, and we place that one center on this scanner prop here. You can place it up here if you want to, although you're going to have to be stepping on it, but you can also hide it away if you want. But just make it center on this platform here. And now let's get back to the coding here. Whoops, I think it just deleted my progress there. Maybe it's over. Okay, there it is. Okay, so input also GPS, and that's also a vector, right? So the position should be equal to the GPS minus the Ranger. Okay. So what it's doing essentially is it's just saying where is the point that it just hit relative to the center, relative to the GPS. Okay. So that's what this is doing. And now we want to emit that, and I actually think, unless I'm forgetting something, I think we just have to connect the position to the position here. And you know what, let's just have an output for color as well, just because I'm not sure it has a color otherwise. So output color, and that's of course also a vector, and we'll just set the vector to be color equals vector 25500, so that's red. Okay, I'm gonna go ahead and connect those. All right, now let's turn it on and see if it actually emits anything when we put something in there, whether or not we did something wrong. I don't see anything for some reason. I don't see anything at all. Did I forget something? I think I might have forgotten something. Oh, I know what I forgot. Okay. I forgot to set the fade time. So these points are pretty much just fading right away. So in this constant value here, we're going to set a third value. And it's just going to be some crazy large number. I don't know if there's a more elegant way of doing this, probably. Going to wire advanced and then fade time, and set the fade time to be the huge number here. And let's go ahead and try again. see if there are any visible points anywhere. I don't see any. I wonder where they have gone. That's a little bit strange. What did I forget? Must have forgotten something. Alright guys, so I forgot to I forgot to wire up the Ranger and the GPS, so obviously nothing's gonna happen if you don't do that. So Ranger input goes to the Ranger position output, and the GPS, of course, is just the GPS vector here. Alright, so now there should be a chance that we can see what's happening. Okay, see, now it's drawing something. The points are way too large, so we can't actually really see what's going on. Let's go ahead and turn the points down in size here to be 5. Oh, it's laggy. Size 5. Let's go and clear this. Okay, let's see now what this looks. Oh, it's doing it out here. It's like it's okay. So the set component is negative right now. Well, that's not good. So let's go ahead and flip these two around. That should make that better, hopefully. Let's see if it does. Oh. No, it's not. So okay. So the set component is still negative. Not entirely sure why that is, but okay. So we're gonna have to find some way of fixing that. So I think, what can we do? How can we do that? Let's see. I think if we just say position equals minus the position, now it's possible that what we're doing now is we're also making the prop mirrored, but at least it's gonna go upwards. Now if you can't live with the prop being mirrored or the projection being a mirror image, then you can also do it by doing it component wise. You just say the X, Y, and Z values and you deal with them separately, and then you just make the set value negative, so it will go upwards instead. But for now, this is what we have, and really we're actually done now. I mean, for the other scanner, I had the scatter mode on here. It's very easy to do that if you want. You can either do it with a sine or cosine chip and just have the cosine or sine chip be connected to some kind of timer and have the timer be going really fast, and then of course what's going to happen is the cosine chip is gonna go back and forth between 1 and -1. Then you can multiply that by some number so that it swings between, say, 0.5 and -0.5, and you will have it go up and down very rapidly like that. That's how I did it. Alternatively, and this is easier, but it's not going to make it look exactly the same, but it's probably going to make it look just as good, if not better. You can just go into you can also do this in the expression chip, but let's just do it out here for now, the chip. So go into a random chip here. Okay, I'm going to place that. Let's just place it here. And okay, it takes 2 inputs. Why does it take 2 inputs? Well, whatever. And let's make it between -0.5 and, well, actually 0.05 and then 0.05. So hopefully. Yeah, so that's now going between those two values. And you just set the, I believe it should be the Y value of the Ranger to be equal to that. And now, as you can see, it's going up and down quite rapidly. And I mean, you really can't tell the difference between this pattern and the pattern from the other scanner. And if you turn it on and you scan now, The only thing that will be different is that the points will be more spread out. So that really is it. That's really this build. Quite a simple build. And I think I'm going to stop the video here because I've been talking for a very long time now. So yeah, thank you for watching, and more videos will be coming soon. So bye for now.